Hello again, everybody. This is the second video for week 4, Algebra 2 Trig Logarithms. First video featured my daughter Kristen for parts 1, 2, and 3, but I'm making this video at 10:30 at night, so she had to go to bed. But part 4, 5, and 6 is the subject of this video. Again, the examples I'm doing here, they're in your notes. They're already done in your notes. I'm making these videos so you can hear an explanation and the thought process to do these problems. Alright, so part 4 of your notes, expanding this out. We have all kinds of properties for logarithms. Most of the time that we use them, it's for solving equations. When we have equations with multiple logarithms, we want to bring them together as a single logarithm, more often than not. And so we use those properties to combine things, condense them. But we can also use the properties to kind of expand things out. Sometimes it's convenient to simplify things when you can expand it out. So the idea here is when you have a log, this one is base 4, of a bunch of stuff, we got to look at what's going on inside this stuff. And we look at those properties. So this is the big thing you notice is it's a fraction. Okay, so that division is going to change. We're going to rewrite this. Basically the numerator and the denominator. We're going to break it up. So it's log of the same base of the numerator. We'll work on breaking this up in a second. But because it's division, minus log of the same base 4 of the denominator. That's our first step. Okay, now this is good. This is what we're looking for this term. But we got to do some work for this first term here. So inside of this logarithm, we are taking the log base 4 of a product. This is 4 times x squared. Because of that times inside of the logarithm, we're going to break this one up into 2 parts. Log base 4 of the first factor, 4, and we go plus log base 4 of the second factor, x squared. And we keep the minus log base 4 of y. That's always going to stick around. All right, so now some next couple of things. Log base 4 of 4, that's one of those properties. When you take the log, think about what a logarithm is. 4 to what power gets you 4? It's 1. Anytime you take the log of a number where that number is the same as the base, your answer is 1. Plus, okay, this, one of those properties, when you have an exponent on top of the thing that you're taking the logarithm of, that exponent moves out in front. Log base 4 of plain old x minus log base 4 of y. Okay, this is what we're looking for with these expanding questions. It's log base whatever of a single quantity where that quantity doesn't have a multiplier on it, doesn't have an exponent on it. This is the idea of what we're looking for. So that's that answer. Condensing it, basically we just go from this and bring it back up to this using the same steps, just going in reverse. All right, the big ideas for logarithms, solving. So, solving with logarithms, it kind of depends on what you're dealing with, what you're starting with. There's some different trains of thought. So here, this really isn't a logarithm equation, it's an exponential function. But logarithms and logarithms and exponentials are inverses of each other. So we use them to solve, just like adding and subtracting, multiplying and dividing when we solve equations. So the first thing is, we're trying to solve for x. It's in an exponent. We need to get this exponential term by itself. We're going to subtract 4. 6 equals e to the 5x. Okay, to get to this variable x in the exponent position, we need to undo this exponential function. It is a base e exponential function. So what we're going to do is take the natural log, which is the logarithm base e, of both sides. Just like we, multiply both sides by 5 or subtract 7 from both sides. Same concept. We're going to take the natural log of both sides. All right. Here we go with these properties. We're taking the logarithm of something with an exponent. That exponent moves out in front. Natural log of e equals natural log 6. Okay. Natural log is a logarithm base e of e. This is just 1. 1 times 5x is 5x. And that's the whole idea. This is an exponential function base e. We applied its inverse logarithm base e. Those two things cancel out, leaving us with just that exponent. This natural log of 6. In the homework, I'm asking for exact answers, so that means don't turn this into a decimal on your calculator. Just leave it alone. To solve for x, this is 5 times x. We got to divide by 5. And that's our answer. Natural log of 6, whatever that is, over 5. Great. All right, this middle problem here. When you have two logarithms equal to each other, this is convenient if the bases are the same. So base 4, base 4. It's just a logarithm of a quantity. Base 4 equals log base 4 of a quantity. There's nothing else attached to it. There's no plus 7s or anything like that. It's just log base 4 equals log base 4. When that happens, what we can do is just jump to those two quantities we were taking the logarithm of. We can just jump to those two things being equal. Essentially what we're doing is, because it's a log base 4, we're going 4 to this power and 4 to that power. Log base 4, 4 raised to a power. Those are inverses. They cancel each other out, putting us here. And then it's just basic algebra to solve. You don't need me to see that. All right, third example. This is the more of the tougher ones, they'll call them. All right, we have two logarithms, both base 2, but we are adding. So here we're using those properties. We're going to condense this. We're going to bring these two logarithms together as a single logarithm. So keeping the same base 2, because it's a plus in between these logs, we're going to bring this together as 3x times x inside of the single logarithm. All right, 3x times x is 3x squared, so let's clean that up a little bit. Log base 2 of 3x squared equals 9. All right, when you are solving logarithmic equations like this, you want a single logarithm all by itself on one side of the equal sign. That's what we got with this. Once you're there, there's a couple ways to think about it, but the easiest way is just rewrite this thing exponential. So base 2 to the 9th power equals the thing that we're taking the logarithm of. All right, now, as everybody knows, 2 to the 9th is 512. 3x squared. All right, I don't have a calculator. I mean, I don't want to spend the time doing the calculator, so I'm going to keep this as exact answers. With this one, it's okay to turn some things into decimals. It's not a big deal, but we're solving for x. We're going to divide by 3. 512 over 3. It's something like 170, whatever it is. It's not exact. But we're going to solve for x, take the square root of both sides. As everybody knows, again, take the square root of both sides, positive, negative, whatever this square root of 512 over 3 is. Sort of two answers. Okay, I shouldn't have circled that. Because in the very beginning of your notes, when you take the logarithm of something, there are some restrictions. The quantity you are taking the logarithm of, it has to be positive. So we're taking log base 2 of x. X has to be positive. We can't have that answer. So I circled it too early. Our only answer is the positive, square root 512 over 3. Only that one, not the negative. I hope that helps. Have a great day.